Good afternoon, my name is Billy. I am a MET 346 student here at Purdue University, New Albany, Indiana. I'm going to talk to you today a little bit about phase diagrams, and we're going to look at two completely soluble metals. Just a little bit about the phase diagram itself. At first, we have three regions we're going to talk about. The liquid region, the liquid plus alpha region, and the alpha region. And these are separated by, first we'll talk about the liquidous line, and then the solidus line. So the liquidous line is, help me out, Eric. The liquidous line is
the point that there can only be, it'll all be liquid. There will be no parts that are solid.
Everything is liquid. All of both metals are completely liquid above this line. When you get below this line at certain compositions, you're going to have portions of liquid and portions of solid. Kind of like if you took little pieces of gravel and dropped down in your fish tank. There's some liquid and some solid there. And then if you get below the solidus line, which is the lowest temperature at which, below this temperature, nothing will be liquid. None of the metal. Everything is solid below this point. We call it the alpha region. It's solid. So if we want to find a certain composition at a certain temperature, then we can take a look over here at this other chart. I've got 4 columns: temperature and alloy, phases, percent composition of nickel, and the relative amount. And we'll talk about those as we come to them. First, let's look at 1100 degrees Celsius, 70% nickel. So I find this is my percent nickel column. Notice we have 0 at this side. I just labeled this increments of 10. So where you have 0% nickel, obviously we have 100% copper. Just label both fields for a little clarity. So if we look at 70% nickel, and we said 1100 degrees Celsius, that's going to be right here on this line. We drew this dotted line across just to show where our temperature was. That's going to put us in the alpha region. So if you come over here to our chart, phase is present, just alpha. Percent composition of nickel is 70% and relative amount 100%. Let's look at 1300 degrees Celsius, 50% nickel. Things will get a little bit deeper. So we find 50% nickel, and we come up to 1300 degrees Celsius. Now, we landed right in the region of liquid and alpha. So we have to draw a tie line. You put one dot right here on the liquidus line, put another dot over here on the solidus line, and you go down from each dot to see what percent composition you have of that phase. So from our liquidus line, we go down, we hit about 42. And from our solidus line, we go down and hit about 60. So you come over here to our chart, 42% liquid, 60% alpha. And the million-dollar question right now is, how can you have over 100% of something in the cup? And the answer to that is you have 42% of the liquid is nickel. 60% of the alpha is nickel. Now, the relative amount we calculate like this. We take the 60, which is the percent alpha, minus the percent composition of the cup. So 60 minus 50 divided by 60 minus 42. Once you divide those, multiply by 100, and you find out that you have 55.56% liquid. So these two they don't have to equal 100. A lot of times they won't equal 100%. These two will always equal 100%, your relative amount. So notice we have 55.56% liquid and 44.44% alpha. And obviously, when we're talking about 42% liquid, then we can say that you can assume that there's 58% other liquid that is also copper. Alright, so let's take a look now at 1150C. Okay, so 1150C at 20% nickel. Come over here. 20% nickel. We find 11. There's 1100, 1200, so 1150. It's about right here. Then I landed again in the liquid and alpha region. So I draw a tie line. Bring those down. I find out that I'm at about 13% liquid nickel, and I'm at about 24% alpha. So again, that means 13% of the liquid is nickel, 24% of the alpha is nickel. The relative amounts would be 24 minus 20 divided by 24 minus 13. Multiply that, answer by 100, get 36.36%, leaving us with 63.64% for the rest of the relative amount. Now, one more. We'll take a look at 1450 degrees Celsius at 40% nickel. So, we'll find 40% nickel. Find us a spot up here at 1400, so 1450, and we notice that, see, there's no need to draw a tie line because your only phase present is liquid. So we can easily go right back over to the chart. 40% nickel, 100% relative amount. So that means 40% of this stuff at this temperature, at this composition, is liquid nickel, and the other 60% of the liquid is obviously copper. So that has been our rundown on phase diagrams. Hopefully we'll have some more stuff up about some other metals that are insoluble and some that are partially soluble. I think there's some other groups going to put those up. So thank you for your time, and if you have any questions, email me at wbeck@purdue.edu. I'd be happy to answer them. Thanks.